Welcome to Dataverax Episode 2, my first piece on data integration, which I have called rather tongue-in-cheek, the pitfalls of computer dating. We'll be talking about dates in computer systems in this episode and some of the problems that you can run into when you start dealing with those things. My name is Scott Andrews. I'm President and Practice Lead at Dataverax Corporation, and I do data analytics and data management projects and also lead trading seminars. If you're going to run into problems with data integration, it is most likely going to be with dates. Dealing with dates can be somewhat vexing. This is because each computer system handles dates just a little bit differently. A key issue with dates is that the date ranges between computer systems do not necessarily line up. This means what is a valid date in one system may be rejected in another. This problem is most evident when you have poor data quality and dates fall outside of their expected ranges. You may be required as well to have special calculations to convert dates between computer systems. As you will see later, there are some date types that do not lend themselves well to being converted to regular date types. Sometimes you may be required to load your dates as strings so you can look at them and see what the problem is in your new data system before you go converting your date back into a regular date type. So why are dates such a strange creature of data? Let's look more closely at some of the standard ways dates are stored and calculated. Julian dates are the granddaddy of all computational date systems. These dates have been used for hundreds of years by astronomers and mathematicians. A Julian date consists of the days in the Julian era, which started at noon on January 1st, 4713 BC. The decimal portion of a Julian date counts the fractional day where each 0.1 unit equals 2.4 hours. To put today's date in Julian form, it would look like this. We have our integer portion showing us a count of days in the Julian era, and a decimal portion showing us where we are at in the day. Now, an important distinction with Julian dates is that the day flips at noon, not at midnight like we would normally expect. The Julian date was created by Joseph Justus Scaliger in 1583, 1 year after the Gregorian calendar was instituted. Why did he choose this particular date? What's so special about January 1st, 4713 BC? Well, this date was chosen because the Julian calendar, the lunar calendar, and the Roman tax calendar all lined up on this date, an event that only occurs every 7,980 years. There are several variations of the Julian date. The first of these is called the modified Julian date, which saw the day reduced by 2.4 million and also modified so that the day flipped at midnight and not noon. This was done for the recording of the Sputnik satellite so that they could have the number reduced to 18 bytes. The second date that I will talk about is the truncated Julian date, which was created by NASA in 1979. Importantly, these flip at midnight, not at noon, as we saw with the classic Julian date definition. There are several more of these Julian date variations, but these are the only two that I will talk about in this presentation. Now you may say, that's all fine and good, but what do we care how the astronauts store their dates? Well, we will soon see how this fits in with the computer systems of today. There are some special things to know about dates in Microsoft computer systems. Excel dates are different from most. If you have ever formatted your Excel date as a number, you will see that it has an integer part and a decimal part. The integer part is counting days, and the decimal part is counting parts of the day. Unlike the Julian counting system, these days are counting from January 1st, 1900. Fun fact, Excel will not let you enter dates before January 1st, 1900. If you attempt to type those in, they will be treated as a string and not as a date. SQL Server also has some special attributes. It had an original date-time data type, which was called simply date-time, and this had a date range from January 1st, 1753 to December 31st, 9999. Now, I had some fun with this one when I was loading data out of an Oracle system that had one date with the year 1080 instead of 1980, and SQL Server rejected that because it was outside of the prescribed range. Since those days, SQL Server has come up with another data type, the datetime2, which will also allow you to go all the way back to January 1st, year one. So now the datetime2 has a range that goes from January 1st, year one to December 31st, 9999. Oracle dates store dates from the whole Julian era, which is to say that they store dates from January 1st, 4713 BC to December 31st, 9999. In this sense, Oracle's system most closely links to the Julian system we first saw in this presentation. Oracle also has a Julian date format that allows you to convert integers back to regular dates and vice versa, which can be used with the 2_ series of functions. This means you can easily convert classical Julian dates back and forth using Oracle functions. Mainframe dates are in a class all by themselves. They are technically ordinal dates, but they are called Julian dates just to be super confusing. I see these most often in SAP data. A mainframe ordinal date format is the last two digits of the year and the count of days in the year. January 1st, 2020 would be 20001. These are called Julian dates in computer lingo, but as you can see, they have nothing to do with the classical Julian date I described earlier. They have a very limited range running from January 1st, 1970 to December 31st, 2069 due to their two-digit year format. Some conclusions for when you're dealing with dates in data integration projects. Watch out for outliers when you're dealing with data sets. Out-of-range dates are usually a data error of some kind. These can be problematic when loading into another system. It is a good time to consider some data cleansing if possible. Converting dates to strings for data transfers will allow you to load any date from one system to another. This is a good fail-safe method that will get your data across, and then you can deal with converting your data once you have it loaded in your target system. And finally, be sure you know what kind of Julian dates you're dealing with. There are many Julian date variations, not only the ones I've described in this presentation. In the world of computer lingo, the default Julian date refers to the ordinal date used for mainframe systems. I hope you have found this video useful and informative. Check back or subscribe to hear more about data integration or other data management topics. Thanks for stopping by, and I will see you next time.